To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Right, children. In this chapter, we are going to discuss the exercise given in the textbook and some extra questions too. So you all have to first write the answers to all the questions by yourselves and then watch whether your answers are correct or not. Okay? Right. So first we are going to do the exercise given in the textbook. First one. Select the correct or the most suitable answer for the questions below. What is the international unit of measuring distance? Distance, displacement, these all are lengths. So what is the SI or international unit used to measure the length, children? Length is measured by meters, right? There are different units to measure length like centimeters, kilometers, millimeters, meters. Out of all these things, the international unit used to measure length is, any kind of length is meter. Therefore, distance is also a type of length. Therefore, it is also measured by meter. Millimeter, centimeter, meter, kilometer. Answer is meter. Number 2. A moving bicycle is pushed from behind. When it is moving to one direction, when you push it from behind, right? So, behind by a child. What will be the change of motion? So, if it is moving to one direction, if someone goes and push it from behind, which means you apply force to the same direction of moving, what will happen to the speed? Speed will increase, right? So, speed increases, speed decreases, it will rotate, direction changes. If it is to the same direction, what will happen? Speed will increase. A moving bicycle is pushed from behind by a child, right? From behind means to the same direction of moving. Speed increases. What is the instrument used to measure force? In the lab we use, this is the Newton spring balance, okay? Pan balance, table balance, Newton balance, electronic balance. Newton spring balance or Newton balance is also correct. Which measurements have a magnitude and a definite direction? Magnitude means the amount or the size, right? What type of measurements have magnitude and definite direction? Those are vector quantities, right? So we will go through this distance and displacement. Now when we consider displacement, it has both magnitude and direction. But what about distance? It has a magnitude but no definite direction, though this is not the answer, right? Displacement and force. Now both of them have, displacement has a magnitude and also a definite direction. Force also has a definite direction and a magnitude, right? The direction we apply force is the direction of force. Therefore, this answer is correct. But we are going to read the other answers too. Force and distance. Force has a magnitude and definite direction, but distance does not have a definite direction. Force only, not force only, but displacement and force both. Right, children? Next one. Which is the correct statement about force? Force has a magnitude only. No, it has a definite direction too. Pulling only can be resulted by applying a force. What is force? A pulling or a pushing is resulted when applying a force. Both of them should be there. Pushing only can be resulted by, no, pulling also there, right? Pulling and pushing can be done by applying a force. That is the answer. Right, we'll move on to the next. Look at this. A child goes to the well which is in the east from his home and returns back along the same route. This is the home, this is the well, right? So this is the direction towards east, right? Look at this one here, given a kind of circular path. This is the actual path he takes, right? So this one you all can see it's a straight line from the first location to the second location, right? Write down in the table the distance traveled and the displacement for each instance given below, right? By looking at this diagram, you have to answer this one, fill in this table. So look at this motion given, distance traveled, displacement given in meters. We'll consider the first one, going from home to the well. From home to the well, this is the path taken. Look at the circular path that is taken. So from home to the well, you all can see the straight line. Again, it is the linear length between the start and the end, the two locations, right? That is the displacement. So we will simply write this is the displacement. This line shows the distance, right? So going from home to the well, what is the distance from here to here? 10 meters to one side only, right? Displacement, here to here, displacement is 7 meters. We'll write 10 meters, 7 meters. Now is it correct? It's not completely correct because displacement has a definite direction. You always have to mention the direction too. So when the boy goes from home to well, he moves to this direction. What is this direction? If you consider this direction as north, right? What is this direction? That is east. So we will write towards east. Towards east. Towards east. Right, children? Second instance, going from well to the home. Well to the home, he takes the same path. Therefore, distance is the same, 10 meters. Right, children? What about the displacement? Again, this time we consider this is the start, this is the end. Again, the direct distance or the linear length between the 2 points is the same, 7 meters. But this time, what happens to the direction, children? Direction changes. Okay, so in the first instance, this is the start, this is the end. Therefore, the boy has moved from here to here, which means towards east, right? In the second instance, we consider this is the start, this is the end. This time, boy has moved from here to here, to the opposite direction, which means to the west, towards west. Towards west. Third one, going from home to the well and returning home, right? Going from, now this is the start, going from home to well and coming back home, right? From here to here, coming back home, okay? So when he goes from here to here, he goes 10 meters, and when he comes back, he comes another 10 meters. 10 plus 10, what is the answer? 20. Right? 20 meters. What about the displacement? He starts from here, right? Goes to this place, comes back home. So at the end, if you measure the linear length between start and the end, as he stops at the place where he started, is there any linear length? No. Therefore, displacement is 0 this time. Right, children? We'll move on to the next. Right. There are some instances given below where a force is applied. Mention whether it's a pull or a push for each instance. Right? This is very easy for you all now. Here, hitting a ball with the bat, hitting, it's a push. Here, one child is pulling this cart, it is definitely a pull. Riding a bicycle, when you ride bicycles, even earlier we discussed, you have to push the pedal forward, therefore, this is a push. Right. Okay. So we have completed the activities given in the textbook. We will do some extra questions now. Right. So exercise 1, underline the most suitable answer. Right? Select the correct statement regarding the distance and displacement. We will read this now, you all are familiar with that. Both distance and displacement have a magnitude and a direction. Is this correct? No. Only displacement has a direction, but distance does not have a definite direction. Both distance and displacement have only a magnitude. They both have magnitude, but in addition, displacement has a direction too. So it's not only a magnitude. Distance has only a magnitude and displacement has a magnitude and a direction. That is correct. That is why distance is a scalar quantity and displacement is a vector quantity. Distance has a magnitude and displacement has a direction. They both have magnitudes and displacement have a direction too. Therefore, the correct answer is number 3. Question 2. A child who walks 500 meters in a straight path, then turns around and comes back to the starting point. The distance traveled by the child and the displacement respectively, which means in order, are. Now, when you get questions like this, it's better to draw a small diagram to show the motion. Okay? A child who walks 500 meters in a straight path. If it's a straight path, we can draw the straight path like this. This is the straight path. Right? We will consider this is the start. A start. Right? A child who walks 500 meters in a straight path. It does not say any direction, therefore we will not mention that. Right? A child who walks 500 meters. We will consider he is walking to this direction 500 meters. Length of this path is 500 meters. In a straight path, then turns around and comes back to the starting point through the same path. He turns around and comes back. We will consider he starts from here, walks 500 meters, turns around and through the same path, comes back another 500 meters to the starting point. So start and the end both at the same place. Right? What is the distance? What is the displacement? What is the distance, children? Distance is to this direction 500 meters. When coming back, another 500 meters. 500 plus 500. What is the value? 1000 meters. Right? What is the displacement? Displacement. So start and end both at the same place. Therefore, displacement means linear length between the start and the end. Here, there's no difference, which means displacement is 0. Right? Okay. So here, you have to find the answer with the distance and the displacement respectively in order. First, there should be the distance, then should be the displacement. 1000 and 500 are not the answers. It should be 1000 meters and 0. Okay? Second one, 1000 meters and 0. Distance 1000, displacement 0. That is correct, but we'll go through them. 500 and 1000. No, 500 cannot be the answer. 0 and 1000. Again, the values are correct, but not in order. Right? According to this one, distance traveled should come first. It can't be 0, no? Right? Okay? So 1000 and 0 is the answer. Distance is 1000 meters. Displacement is 0. Right, children? We'll move on to the next. Right. Select the incorrect statement. An object at rest can be moved by applying a force. We learn about effects of force. Right? We learned that the object at rest can be moved by applying force. That is correct. The direction of motion can be changed by applying force. Yes. Right? In cricket, when the ball is coming towards the batsman, using the bat, he can change the direction of the motion of the ball. Right? The speed of a moving object can be changed by applying force. That is also correct. Right? In moving vehicles, speed can be increased using accelerators. Speed can be decreased using brakes, right? A moving object cannot be stopped by applying a force. We can stop a moving object if we apply force, right? Let's say if a ball is coming towards you, when you catch it, it will stop, right? Catching, you have to apply force. So moving object, the incorrect statement is a moving object cannot be stopped. It is wrong. Right, next one. The standard international unit of measuring force. What is the SI unit, children? That is Newton. What is the symbol? Capital N. Newton, joule, watt, volts. Answer is Newton. Next one. Number 5. Select the incorrect statement again. The international unit of measuring both distance and displacement is the meter. Distance and displacement both are lengths. Lengths are measured in meters, centimeters, kilometers, likewise. So the SI, standard international unit of measuring length, is meter. That is correct, right? Distance is the total length of the path of a motion. That is also correct. Distance means during a motion, the total length traveled by the object is known as the distance. Next one. Displacement is the linear length between the starting and ending points of a motion. That is also correct. When you consider a motion, the linear length between the start and the end, which means the shortest possible distance, is known as the displacement. The international unit of measuring distance is meter, while the international unit of measuring displacement is the kilometer. No, they both are lengths. The standard unit of, or the international unit of measuring lengths is meters. Therefore, for both of them, it should be meters. So you have to select the incorrect statement. That is the fourth one. Right. Okay. Right, children. We'll move on to the next. Right. Exercise number 2. State whether true or false. Okay. The total length of the path of a motion is called displacement. The total length of the path of a motion. So if you consider the motion, if this is the start, and if an object moving like this and coming to this point, this is the start, this is the end. Right? So we always call this total length traveled as distance, and when we consider the shortest possible distance or the linear length between the start and the end, this is called the displacement. Okay, children. So the total length of the path of a motion, total length of the path of a motion is called displacement. No, that is called distance. Therefore, it is wrong. We will write F. Number 2. Distance is a quantity only with a magnitude. Distance, it is this. It has a magnitude, it is no direction. Therefore, that is correct. Distance is a quantity only with a magnitude, no direction. That is true. The shape of an object can be changed by applying a force. Yes. When we mold clay, this is what we do. We apply force and we can change the shape of a piece of clay. Right? That is also true. Next one. Newton's spring balance cannot be used to measure force. No. This is the instrument we use to measure force. It is calibrated in newtons. Using newtons, we can measure the force. Okay. So this is false. Next one. Pulling or pushing is known as applied force. Yes. Every time we do something, if we look into that carefully, the activity, it is either a push or a pull. So when we do something, physical activity, we always apply force. Therefore, pulling or pushing is known as applying force. That is true. Right, children? Let's move on to the next. Exercise number 3. A child who started to walk from A passes B and C points and reaches D. Look at the motion. Right? A child who started to walk from A, so this is the start, passes B and C points and reaches D. This is where he ends, right? What is the total distance traveled? Total distance traveled means the length of the path he took. First he goes from here to here, it's given it is 10 kilometers. Then he moves from B to C, here it's given 5 kilometers. Then he moves from C to D, length is not given. But you all can see this looks like a part of a, all these are straight lines and this looks like a part of a rectangle. So you all can easily identify length of DC line is equals to the length of AB line. Therefore, here we will write that is also 10 kilometers. Right? So what is the distance traveled? We can simply write 10 kilometers plus, then 5 kilometers plus another 10 kilometers equals 25. Right, children? What is the displacement of the child? Now, when you consider this motion, what is the displacement? The child has actually moved from right at the end of the motion. This is the start, this is the end. At the end of the motion, child has moved, right? Finally, this is the linear length. From between A and D, you have to consider the linear length between the start and the end. Start is A, end is D. This is the linear length. So here, by drawing this one, you all can see we complete the last side of the rectangle. 3 sides are completed, this was not there. So if this one equals, then this side should equal, AD should equal BC, which means 5 kilometers. Right? This should be 5 kilometers. Right, children? So displacement means the linear distance between AD. So what is the displacement? 5 kilometers. You need to mention the direction too. Right? So this is the start, this is the end. So what is the movement? From here to here, A to D. Therefore, this is the direction. What is the direction? If you consider this is north, this is towards south. Right? 5 kilometers towards south. Right? Okay. What is the standard unit used to measure displacement? Right? What is the standard unit used to measure displacement? Displacement is also measured in the same way as distance. That is meters. Meter. Right, children? We'll move on to the next. Right. So, the other part of the question. If the child comes back to A after passing B, C and D. Now earlier, according to the earlier motion, the child starts from A and stops at B. Okay, but here it says, if the child comes back to A after passing B, C and D, if he comes back to A, then what happens, children? The start and the end are at the same place. Okay, so what is the total distance traveled? Now earlier the child travels 10 kilometers, 5 kilometers and another 10 kilometers. If he goes back to A, he travels another 5 kilometers. So this time 10 plus 5 plus 10 plus another 5. AD is 5 kilometers, which means 30 kilometers. 30 kilometers. Right, children? What is the displacement of the child? If he goes to B, C, D and comes back to A. So displacement means the linear length between the start and the end. If he comes back to his starting point, which means there's no linear length between start and the end. That's the same place, which means direction is 0. What is the difference between the distance and displacement? Distance is 30 kilometers, displacement is 0. What is the difference? 30 kilometers minus 0 means 30. 30 kilometers. Right, children? Okay, we'll move on to the next. Right. Exercise number 4. Write 2 instances where the speed of a moving object is changed by applying force. Okay, what are the instances? We can simply write speed of the vehicle can be increased by, how do you do that? By using the accelerators. Speed of the vehicle can be decreased by applying brakes. Okay, the speed of a bicycle can be increased by pedaling fast. Okay, children, and the speed of a bicycle can be again decreased by applying brakes. Okay, children. Likewise, we will write 2 of them. Write 2 instances. The speed of a car can be increased using accelerator. Speed of a car can be decreased by applying brakes. Right? The speed of a car can be increased using accelerator. The speed of a car can be decreased by applying brakes. Okay? Number 2. Write 2 instances where the direction of a moving object is changed by applying force. The direction of a moving object is changed by applying force. Right? The direction of a ball can be changed. In cricket, direction of a ball can be changed by batting, using the bat. Right? And earlier we learned that in tug of war, the 2 teams pull the ropes to either side and changes the direction. Okay? We will write them. Write 2 instances. When playing cricket, the direction of the ball can be using by hitting with the bat. In tug of war, the direction of the moving rope can be changed by pulling it. Right, children? So when playing cricket, the direction of the ball can be changed by? Can be changed by. Can be changed by hitting with the bat. In tug of war, the direction of the moving rope can be changed by pulling it. Right, children? We are moving on to the next. Right, exercise number 5. The way how a hook is attached to a rubber band that is fixed to a support is given in the following diagram. Look at this. This is the support, this is the rubber band and the hook. Right, let's go through this. Draw diagrams to show how the length of the rubber band changes when bags with 1 mango, 2 mangoes, 3 mangoes and 4 mangoes are hung respectively. Which means there are 4 bags, okay? In one bag, 1 mango, another one, 2 mangoes, in the next one, 3 mangoes and the last one, 4 mangoes. So what you have to do is, if you hang these bags in this hook, you know that this rubber band will stretch at different levels. You have to simply show using diagrams how it stretches. Right? So you all know when the number of mangoes increase, what happens, children? The mass also increases. Now we know that when the mass increases, force applied also increases. When the force applied increase on the rubber band, what happens to the length that it stretches? It also increases. It stretches more. Okay? We will draw this as diagrams, children. So, first of all, we will draw the support. Right? We'll draw the support and then the rubber band. We'll draw the support all 4 at the same time. We need to draw 4 instances. Right? So what can you tell about how the rubber band stretched at each instance? In the first instance, only a less one. Next one, with 2 mangoes, it stretches more. 3 mangoes, longer. 4 mangoes, it stretches the most. Okay? Right. So what you have to show is, when the number of mangoes increase, what happens to the length of stretching of this rubber band. Okay? Right. Only 1 mango here. Right, in this bag, 2 mangoes. In this bag, 3 mangoes. And here this one, you can draw 4 mangoes. Right, children? So what you have to show is how the length of stretching this rubber band changes. Even during an activity, we did this. So when you hang the bag with 4 mangoes, it stretches the most. Okay? Right. Number 2. Briefly describe the reason for the above observation. The observation was the rubber band stretches more when more mangoes are hung. Right? What is the reason? Because when more mangoes are hung, what happens, children? When the number of mangoes increase, the mass also increases and more force is applied. Right? Due to the increased force, the rubber band stretches more. Right? We will write. Briefly describe the reason. When number of mangoes increases, the mass also increases. Mass also increases and force is applied. and more force is applied. Due to the increased force, the rubber band stretches more. Right, children? When the number of mangoes increases, the mass also increases and more force is applied. Due to the increased force, the rubber band stretches more. Right? Number 3. Name the instrument that is used to measure the weight or force of an object that functions according to the concept you mentioned above. So as similar as this setup, what is the instrument, children? Newton's spring balance. Right? Newton's spring balance. Newton spring balance. Right. Next one. In the instrument you mentioned above, what is present instead of the rubber band? Rubber band is the stretchy part. So when you consider the Newton spring balance, instead of the rubber band, what is the stretchy part present, children? The metal spring. Okay? The metal spring. The metal spring. Right, children? So in the instrument you mentioned above, what is present? Instead of the rubber band, it is a metal spring. Right, children? We move on to the next. Right, exercise number 6. Define what force is. What is force? Now we learned. The pulling or pushing is known as applying force. Okay? Pulling or pushing is known as applying force. Applying force. Pulling or pushing is known as applying force. What is the standard international unit of measuring force? What is it? It's Newton. Right? What is the symbol of it? Capital N. Right? Unit Newton. Symbol. What is the symbol, children? Capital N. Right, children? We'll move on to the next. Right, number 7. In which type of motion do the distance and displacement are same? Now, do you remember when we were doing the lesson, we discussed that most of the time when we consider a motion, displacement is less than that of distance. But in some instances, distance and displacement are the same. What type of motions are these? Linear motions. When a certain object moves through a straight path or a linear path, the distance and the displacement will be the same. Right? These type of motions are known as linear motions. Okay? In which type of motion do the distance and displacement are same? Linear motions. Linear motion. Right. Write 3 examples of the above type of motions. What are the examples, children? You can consider, even during the lesson we discussed that, running 100 meters. When you run 100 meters, it always takes place in a straight track. Okay, length of the track is 100 meters and that is straight. Okay, what else, children? When it is falling, fruit on the tree falling on the ground, what happens, children? Fruit on a tree falling on the ground. Right? That is also because of the gravity of the ground, it always comes straight. Okay, children, in the same way, when we throw something up, it comes down also in a straight path. Right? You must have seen sometimes some children, when they play, they shoot pellets with rubber bands, or maybe sometimes when you shoot stones with slingshots, again, the path of the stone is also a straight path. Okay, shooting an arrow with a bow is also the same, right? We will write some of these examples. Right. Number 1, running 100 meters. 100 meters, we'll write race. Number 2, a fruit falling from a tree. A fruit falling from a tree. Number 3, we can write shooting a stone with a slingshot. With the slingshot. Right, children? Write 3 examples of the above type of motion. Running 100 meters race, a fruit falling from a tree, shooting a stone with a slingshot, shooting an arrow with a bow. Those type of examples you can write. Okay? We move on to the next. Right. Exercise number 8. A route for a child to travel from his home to his school is shown in the following diagram. So we are familiar with these type of questions now, right? What is the total distance traveled by the child? So we'll consider this one is home, if this is the school, right? You all can see the lengths of each part is given. Here you all know that the distance traveled is the total length of the path taken. Here, this is the path taken. From here to here, it's given 20 meters. Here to here, 40 meters. Here to here, 50 meters. Then this one, 60 meters, 20 meters, 10 meters. Right? Let's write 20 meters plus 40 meters. We will write meters outside the bracket. Right, 20 plus 40 plus 50, right, then 60, then another 20 and 10 meters. Right, children? So the answer is 200 meters. 200 meters is the answer. Right, children? 200 meters. 20 plus 40 plus 50 plus 60 plus 20 plus 10 equals 200 meters. Right? What is the displacement? What is the meaning of the displacement? The linear length traveled between, or the linear length between the start and the end. If this is the start, if this is the end, now that length is not given. But using these other lengths given, we have to find it. You all can see when you consider this dotted line, this dotted line, right, this dotted line, this one and this one. It makes a rectangle, right? So this line is given 40 meters, therefore this line above also should be 40 meters. Okay, children, this also should be 40 meters. Right. We can take this as 40 meters, this length. Now we have to find the length between this one and this one. The same way, you all can see there's another rectangle here. This one using this line, this line, this line and this line. Right? So here the above line, the top line's length is 60 meters. What about the bottom line? Only part of the bottom line. Now, the bottom line also should be 60 meters. Top one 60 meters means this one also should be completely 60 meters. Right, this length. But we need to find the length from here to here only. Only this part should be found. Right, so you all can see here to here distance is given in 10 meters. It is given as 10 meters. Therefore, what is this length? 60 minus 10 means 50 meters, which means this distance is 50 meters. How did we find it? Right, using a different color, I will show you how did we get this 60 minus 10. Because this entire line is 60 meters. Why is that? Because this top line is 60 meters. Because it's a this is a side of a rectangle. One side is 60 meters means the other side also 60 meters. Right? Up to this part given as 10 meters. Therefore, the other part what we need to find must be 60 minus 10, which means 50 meters. So what is the displacement from this point to this point? So here to here is 40, here to here is 50. So we have to get you have to add it up. Displacement is 40 meters plus 50 meters equals 90 meters. 90 meters is the displacement of the child. Distance is 200 meters. Displacement is 90 meters. Right, children? What is the total distance travelled by the child considering the motion of going to school and coming back home? In the morning he goes to school and in the afternoon he comes back home. So when you consider the entire motion, what is the distance? You all can see just to go to school from home, the distance is 200 meters. So to come back, another 200 meters because he takes the same path. Okay? So 200 plus 200, 400 meters. 200 meters plus 200 meters equals 400 meters is the answer. What is the displacement? Starting from home, he goes to school and coming back home. When he comes back home, he comes back to his starting position. So what is the linear length between the start and the end? There's no length, there's no difference. It's the same point. Therefore, the displacement is 0. Okay? Displacement is 0. Right, children? So I hope you got this correct. We did many examples like this. Right, children? We'll move on to the next. Right. Exercise number 9. A child throws a ball 20 meters up and catches the ball coming down. Right? Assuming the motion of the ball to be vertical. Right? Vertical movement. We will simply draw a diagram to show this one. Right? The ball moves up 20 meters. Right? We'll consider this is the start. The ball moves up. This should be 20 meters. And it comes down through the same path. Right? It goes up and then it comes down. Right, children? What is the total distance traveled? It goes 20 meters up. Again, it comes down another 20 meters. So 20 plus 20. 20 meters plus 20 meters equals 40 meters. Right, children? What is the displacement of the ball from its highest position? What is the highest position after throwing it up? This is the highest position. If you consider this highest position, what is the displacement? Displacement means the linear length between the start and the end. If you consider this highest position, this is the start, this is the end. So if you consider the motion is vertical in a straight line, what is the displacement? that is also 20 meters. Okay, that is also 20 meters. What's the displacement of the ball after catching it? Here, after catching means when the ball is thrown up and when it comes down, you have to catch it again. So when the ball goes up, it goes 20 meters and it comes down another 20 meters to the same place, right? And after coming it down and after catching it, start and the end are at the same place, which means there's no linear length between the start and the end. They are the same place. So what is the displacement? This time displacement is 0. Right, children? We'll move on to the next. So this is our last question, right? Write 4 things that can be done by applying force. Now you know many things that can be done by applying force. You can move an object at rest by applying force. At the same time, you can stop moving objects by applying force. What about the direction? Direction of moving objects also can be changed by applying force. Right? And at the same time, you all know that the shape of the objects also can be changed. Right? The direction or the speed of the motion also can be changed by applying force. Right? We will write some of them. Number 1. An object at rest can be moved. An object at rest can be moved. A moving object can be stopped. The direction of a moving object can be changed. Number 4. The shape of an object can be changed. Right, children? Write 4 things that can be done by applying force. An object at rest can be moved. A moving object can be stopped. The direction of a moving object can be changed and the shape of an object can be changed. Right, children? So we have completed the entire lesson now. We learn the difference between the distance and the displacement. And then we learn about force, and now we know that what are the things that we can do using force as well. And after that we answered a lot of questions too. I hope you got a good understanding on this lesson.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.